everybody hear my voice?
Yes, sir.
Okay,
Yes, sir.
very good. Okay, now we recap back on chapter 1. Chapter 1 deals with introduction, element of communication system, transmission media, transmission modes, electromagnetic spectrum and transmission frequencies, bandwidth, information capacity, noise. Noise, you got external and internal, signal noise ratio, noise factor and noise figure. Okay, now so want to clear cut before we start something like so want to tell you something. The important thing of in chapter 1, okay, normally in chapter 1, normally in chapter 1 the basic concept, okay, chapter 1, so want you to know about this thing first. So want to know, this is very important. Okay, you got power, okay, you got voltage, you got current. Okay. Now, after you see the last class, I give you the video, right? YouTube, right? Now, so want you to know about this thing, okay? And then gain, okay, and then attenuation, and then you learn on noise figure, noise factor, and so on. And then you learn on ideal amplifier, and also non-ideal amplifier. Okay, now some of you said, "Sir, why we need to do Google Meet?" Okay, because I want to tell you something different. When you see the YouTube, yes, you know about the YouTube, but once we have the synchronous class, you can give the feedback at the same time. Correct or not? Okay. Now, this is the thing that you want you to remember, and then the new term. Okay, remember this is new term. The new term that you will learn on something like, okay, new term, dB, decibel, and then you learn on dBm. Okay, this is the term that you will learn on chapter 1. Okay, now let's start. So recap back. Okay, so recap back. That's why when Sir said Google Meet means important. If you don't come, means you will escape this thing and then you don't understand the rest of the chapter. Remember, synchronous class mean we interact. Okay, I give you something, you give me back. Okay, for example, chapter 1, we got some error. Okay, miscalculation. That's why you must come. Okay, you should know something. This chapter teach by 3 lecturer. Okay, now let's move on. We do recap. Recap what you already learned on last class. Last class you already see YouTube. YouTube dealing with you check in your if you check in your column. Okay, let's check for a while. Double confirm. Don't worry. After this one, you understand. No need to do synchronous class. Okay. Okay, let's check. Okay, let's look on your principle of communication. Okay, so basically you can check this your syllabus inside the column syllabus here. You can download, and then you see chapter 1. Chapter 1 last class give you video. Video introduction to electronic communication system. I give you 3 video. Okay, impact led, and also actually extract from this column. Okay, and then introduction power measurement. Okay, gain, attenuation, and decibel, and also noise analysis. Now, when you already see your YouTube, so we need to double confirm whether you understand or not. That's why my class something like that. We double confirm. Do you understand or not? Because some things on the slide you don't understand. For example, simple thing. For example, log 2, how to, and then some error appear on your slide. That's why you must come to this class. Okay. Okay, now we go back to our slide. Okay, now so recap back. Okay, so introduction we already do the revision. Okay, and then element of communication system we already cover in the YouTube in the video, and then element of communication system where you need information, and then transducer, transmitter, receiver, output transducer, destination. So I already explained you before. This one just recap. Okay, now information source, input transducer we already cover. Okay, okay. Transmitter already cover. Okay, channel medium already cover. Okay, noise we got internal noise and what? Internet and what? Huh? Say something lah. Huh? Internal noise. And then what is another one? Okay. Okay, this one guided media you already know. We already cover up optical fiber, coaxial cable, and then unguided media. Okay. Okay. Then we go to the simplex, half duplex, full duplex. Last time, so I already told you about simplex, something like the analogy of your radio, half duplex, walkie-talkie, full duplex like your smartphone when you contact your friend. So now, okay, you can, this one we already covered. Now, so want to go on most important thing, spectrum we already cover, okay. Frequency range already cover. Okay. Okay, start from here. Exercise 1. Okay, this one is the one we need to focus. Okay. Exercise 1. Okay, what is the wavelength? Okay. So we cover back wavelength. You must know the how the location of the wavelength, amplitude, velocity, frequency period, wavelength, lambda, t. You must know from this figure. Actually, this one is the basic thing. During your secondary school also teach this thing. Okay, but we recap back. Okay. So C equals to F lambda, lambda equals to C over F. Very simple. So what for exercise number 1, recap, make sure you take piece of paper and so on. We do back this example. So C, what is the C? C is a speed of light. Okay, 3 times 10 power of 8. Okay, meter per second. And then how about frequency? Frequency dia 101.1 megahertz. And then you ambil calculator. Berapa jawapan dia? Somebody tell me what is the answer? Take out your calculator. Okay, this is synchronous, mean we interact. So what's the answer? So what's the answer?
2.96. 2.97.
Okay, wait for a while. Okay, 2.97
97.
times.
No time, sir.
No time, 2.97 only.
Yeah.
Okay, so what's the value? Meter or what?
Meter per second. Meter.
You check back, wavelength, you check back the unit. Okay, 2.97 watt. So that's why you come to this class. Then you can double confirm the unit. Okay. Lambda meter, if not mistake. Correct or not? Okay. Now, exercise 2. Okay. Given the frequency, actually this one meter. Wavelength is meter. Okay. 2.97 meter. Okay, now exercise 2. What is the frequency of the signal whose wavelength is 8 cm? So lambda 8 cm you must change first. 8 cm to meter. 8 cm you press calculator, got 0.08 meter. Lambda f. So the question, what is the frequency? Frequency C divided by lambda. You manipulate from this frequency. Okay, F equals to C divided by lambda 3 times 10 power of 8 divided by 0.08. So what's the answer? Press the calculator please. You must do interaction. So what's the frequency?
3.75.
3.75
3.75 power of 9.
power of 9. Correct or not? Yang the rest, okay ke? Betul tak jawapan ni? You jangan
Betul sir. Betul sir, betul sir.
we must do interaction
Betul, sir.
mahal tau. This class mahal tu sebab apa? You guna data satu kelas guna data. Clear? Jadi this is interaction. Nanti saya nak tanya you quiz after finish this. Okay? Okay. Now, bandwidth and information capacity. Yang ini, okay. Formula bandwidth we got two. Okay. The first one, you kena tulis kat kertas tau. Fmax bandwidth equals to Fmax minus Fmin. You kena take note. That's why semalam you tengok YouTube, sometimes you tak faham. You don't understand now, you akan faham satu thing. Saya kata write down. Student saya ramai A sebab dia dengar cakap saya. Listen to me. Okay. Fmax minus Fmin. Semua dah salin tak? Everybody already salin? Okay. Now, let's look on the example. Saya show you example. Okay. If you're given this frequency spectrum, okay, between 300 to 3000 Hz, okay, what is the bandwidth? Bandwidth simple, Fmax minus Fmin. So in this case, Fmax equals to, so bandwidth equals to Fmax 3000 minus 300. So what's the answer? Right or not? If you want to say yes, you must on your microphone. Don't say, yes. For those, okay, remember something. For synchronous class, for those of you, something like you don't want to talk with sir, make sure you just say, oh yeah, correct. What's the answer? 2700. Sir want you to do interaction, even you don't turn on your microphone. Clear? Senang you tak on microphone pun, you cakap dengan diri you sendiri, so that we got the interaction. Clear? Okay, now information capacity. What is the kind of information capacity? Something like is the measure how much information can be propagated through a communication system. Okay. Now the formula is ini ada silap. This we got satu yang silap. Okay. Ni silap technical. So I betul kan? I equals to B log 2 1 plus S over N. Okay, betul kan? Dah betul dah. Okay. So clear. Okay. Now, concern on this thing. Katalah kita bagi sebagai exercise. Okay, student tak reti guna. You don't know how to do. Okay, for this example, saya bagi tahu you. You tak reti jawab. Okay, tengok macam mana. Even you got the formula because technical issue you tak reti guna calculator. This is normal. Okay, now sebagai tahu you something. Let's say given the signal to noise. Okay, remember signal to noise normally in the dB. Okay, how you got the dB? After this, I told you. Okay, that's why I said telling you something. dB. Okay, dB. They say something. Okay, whether 10 log or 20 log. After this, I show you. Okay, now how to do this? Okay, now you already know S over N 40 dB. Okay, 40 dB, and then bandwidth 3.3 kilohertz, and then how to do the you want to find I, okay, information capacity. So you already know I equals to B log 2 1 plus Sn. Now some of the students don't know how to do B log 2 plus 1 over Sn. How to pressure log 2, correct or not? Some of you don't know, right? Okay, now easy. Okay, 3 point, you take this value, put here. Okay, 3.3 kilohertz log 2 1 plus S over N. Okay, this is the thing that you must know. Okay, S over N. Okay, the value in dB. This is I'm telling you something. Okay, normally S over N is on power. Okay, now so telling something. Okay, new thing. That's why you don't come to this class, you don't know. Okay, dB. I told you something before we start. Actually, dB. Okay, if you do voltage, that's why you take down, take note. Okay, if the voltage, for example, your actual value is 1000 volt, for example, 1000 volt, and also power. Power equals to 1000, for example, okay, watt. Okay, actually both of these can be converted to the dB. Okay, before we do the up one. Okay, so in dB for voltage is 20 log 1000 volt. Okay, for watt different, become 10 log 1000 watt. So press the calculator. What is the value you got for voltage in dB? 20 log 1000. What is the value?
60.
60 dB. Okay. Here 10 log 1000.
30.
30 dB. That's why I still want you to bear in mind, even you got the value 30 dB and 60 dB, you don't know. But if you understand the concept and so on, you will already understand, oh, this one actually related with power. That's why when you see this 40 dB, if you don't come to class, so which one? Is it power? Is it voltage? That's why you come. So remember, if you use Shannon formula related with power. Okay, so let's say you got 40 dB, for example, 40 dB. How to get the okay, actually, this one, telling something, this one we call as a real value. Okay, clear or not? Okay, now, before we start this example, okay, let's say 60 dB. Let's say I give you 60 dB, right? Okay, convert back, 60 dB, convert back how you got the voltage. How you press the calculator. Okay, now you already know, right, 1000, but so want you to press how you want to get, for example, dB to real value for voltage. Can you get 1000? Please press your calculator. How you do it? Okay, right now, for example, okay, given 60 dB voltage, for voltage, voltage 60 dB. Okay. Okay, convert to actual value. So what's the answer? We already know 1000, right? But how to do the inverse process? Okay, this is the thing you must know. Convert to actual value, voltage. Okay, how to convert? Simple. Okay, let's say, okay, for voltage, 20 log V equals to dB. Okay, equals to 60 dB. So how about the V? V equals to 60 divided by 20 anti-log. Correct or not? Anti-log. Correct or not? Okay, so what? How to press anti-log? This is the things I want you to show you. Okay, how to do anti-log? You press shift. Everybody got calculator, that's why you don't press a calculator, you cannot answer. Okay, shift log. Everybody press that thing? Everybody press that thing? Shift log 60 divided by 20. So you got the original value, 1000. Correct or not? Correct or not?
Yes.
Correct,
sir.
Yes, sir.
That's why you come here today. Okay, now, after you finish this thing, can you get this value? Okay, actually, this S and N, this one related with power. Okay, so when you want to apply in this formula, actually, this is the real value, value. Okay. Okay, this is that one is real value. Okay, so you must convert. In order to solve this thing, first you must convert. You must convert. Okay, you convert first. 40 dB. Okay, this one 40 dB. In watt. Okay, now 10 log P equals to 40 dB. So P equals to 40 divided by 10 anti-log. So what's the answer? Anti-log 40 divided by 10. What's the answer?
10,000.
Huh?
10,000.
10,000, right? So you got
Yeah.
this answer correct not? Okay, so put the real value plus 1. Now, how to solve log 2? Correct or not? Can you press log 2 in your calculator? Can or not?
No.
No, right? That's why you should come to this class. Okay, now. So telling you something, in order for you to solve this problem, okay, look at this part. Calculator, how to solve it. Okay, first press log 10,001. Everybody press. Okay, and then divide by log 2. So you got 13.28. Please do this example. If that's why you don't do this, fail. Chapter 1 fail. Okay. So you got 13.28. Dapat tak semua 13.28 this thing? 13.28.
Dapat.
Tak dapat. For those tak dapat, now talk. So when you turn on your microphone, jangan malu.
Sir.
Ha?
Tadi apa dia cakap? Log 10,001 divided by?
Bukan let 10,000. Press log 10,001. Sorry. Kan sebab ni total value kan? Press 10,001. Okay, dah press dah?
10,001. Dah.
Okay, and then divide by log 2.
Log 2, okay.
You got 13.28 or not? Jangan malu, jangan malu. Asking me.
Yes, sir, yes, sir.
Okay, siapa tak dapat lagi in this class, please. Ini this introduction, nanti chapter 2, 3 you takkan faham lagi. Now, tell me. Siapa tak faham, tanya sir sekarang. Asking me now.
Sir, log 10,001 divided with log 2.
Betul-betul.
Okay.
Boleh? Okay, press now. Tak dapat, saya tunggu 2 minit. Sebab this is introduction, sebab tu selama dekat introduction. Nanti ada chapter laju je. Okay. Okay, everybody got it? Jangan malu-malu.
Sir,
Semua dapat?
nak tanya, kalau kita guna calculator yang boleh tukar value log, boleh ke? Nanti.
Log macam mana? Saya tak kisahlah. If you got the calculator, got this value, no problem. This one untuk calculator yang sahaja slow. How to change if you see log 2. Pertama, kalau you ada calculator canggih, no problem lah. This one for untuk orang yang macam tak ada duit macam saya, sebagai calculator M570. Kalau yang kaya 500, 900 mod, 900 something, you boleh. Okay? Okay, so dapat tak? Kalau you dapat, saya nak proceed ni. Value,
Dapat sir.
okay, the value is kilobit per second. Bit per second. Nanti you belajar dalam digital. Now chapter 1 you dengar dulu kilobit per second. Take note that thing. Okay? Okay, everybody clear? Now saya nak pergi seterusnya. Noise type. Okay. Clear? Saya pergi noise type. Okay, noise type actually we got in internal dan external. Okay? Internal, you got short noise, thermal noise, okay, transit time noise, flicker noise, and so on. Ini sudah cover itu, okay, don't worry. You baca pun you boleh faham, okay, because this is all theory, okay. Okay, main mic noise, you boleh baca sendiri, okay, internal noise. Sudah recap balik. Okay, now, we go to, ini pun dah, thermal noise sudah, so also done. Okay, now, ni satu lagi, okay. Direct formula, okay. Ni saya nak bagi tahu. Example. Ini related with noise. See? Nampak tak saya cakap? Dia selalu related dengan P and V. Sebab tu dB, dia ada dua saya cakap tadi. In term of voltage, lepas tu ada satu lagi, in term of power. Okay. V, 20 log. Okay. V. For power, 10 log P. Dia related. Okay, the analysis like that. Okay. Okay. Now, direct formula ni tak ada pun masalah. Saya cuma nak bagi tahu this one for direct formula. Okay. Cuma sometimes you kena faham. Kelvin. Sometimes kita give you in Celsius. Yang lain saya tak kisah. This is mathematical. Dia tak ada pening masalah. Okay. So, kalau dalam kes ni, Pn equals to KTB. K dapat mana? K dalam memang dia punya apa orang panggil? Punya constant dia. Okay. Memang dah ada, dah dibagi. Jangan takut. This one Boltzmann constant. Okay. 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 Remember, if I give you in Celsius, you must Kelvin. Kelvins equals to 273 plus Celsius. That's the thing only. The rest direct formula. That's why I don't want to teach you much more. You can see apply the direct formula. Okay, and then Vn. Okay, Vn equals to for KTBR. Actually, this is direct formula. Okay. Okay, watt and voltage the value. Okay. Now, example. This one. Okay. Now, actually, this example got error problem. Okay. You see, before this, I'm telling you about dB, voltage and power. Correct or not? Now, we also got another term in dBm. Actually, please don't scared. It's something like, okay, you want to do cake, for example, cake. Okay, how many flour you want to use? Sometimes you give in term of 0.5 kg. Sometimes you say 500 grams, something like this. In com also we got dB, dBm, no problem. Okay, but so want to give you analogy about dBm. Okay, dBm. Okay, how to get the dBm? Okay, simple like this. Okay, so give you one example. Okay, before we start this one actually wrong. Actually, the solution is wrong. Okay, solution wrong. Okay, so correct back. Okay, now, so how to solve it? Okay, so telling something, what is the dBm? Okay, dB for voltage 20 log V. For power 10 log P. Then how do you convert to dBm? Very easy. dBm equals to dB plus 30. This is simple formula. Okay. dB plus 30. Okay, now, or dBm. Okay, wait. Okay, let's look on this example. Okay, the one I keep first. So that you know. Okay, now, given that Pn equals to 105 dBm. So, for bandwidth equals to 8 megahertz. Okay, now remember, if you want to use this formula, remember KTB and this one, this is actually a real value, not dB. dB, the operation now, another thing. Operation for dB, dBm, KDBC, this is common, dBc, and so on. Actually, you can only add the operation. You can only add or minus only. Okay. Okay. You cannot do multiply. You cannot divide. Okay. Wrong. This one wrong for dB, dBm, and so on. Take bear in your mind. Okay. So now how to solve this? Okay. So telling something. Okay. Pn equals to minus 105 dBm. Remember, this one is not the real value. So, convert. If you use calculator, to show you something. If actually, this one we got calculator. Okay, now negative 1 dBm. Let's say we press calculator. Internet calculator. So, to show you, so that you don't scared. Okay. dB to watt calculator. Okay, let's say what's the value? Negative what? What's the negative? Negative? What's the value?
105.
105. Convert. So the value is 3.16 times 10 power of negative 14. Correct or not? Correct or not this one? Okay. So the value 3.16 times 10 power of negative 14. So show you what's the value? 3.16, right? Times power of negative 14. Correct or not?
Correct, sir.
Yes, sir.
Okay.
Correct, sir.
Now let's look on the normal calculation. Okay, normal calculation. Okay. So this is the direct value of watt. Here is wrong, See, 10 power of negative 11, wrong. That's why I'm telling something, so can check. Okay, actually this slide is not due by me, Okay, now so telling something, how to do this? Okay, very simple. Okay, in order to you to convert dBm, for this analysis, normally so telling something, for the analysis in power and noise, in noise, normally we are using power analysis. So how to do this? Okay, sky noise power, see, the term also stated here, sky noise power. Okay, sky noise power means we're using, if it actual to dB, then log. Okay, and then if you convert dB to dBm, okay, means dB plus 30. Okay, and then we got another term. Okay, this one, the second step, so want to show you. Okay, very simple like this. Actually, for dBm, actually the formula is 10 log. Okay, let's say 10 log actual. Okay, divided by 1 milli. Okay, this is the formula. Okay, actual value, 10 log actual value divided by 1 milli. But in this case, how to do this? First, negative. Okay, now so telling something. Okay, now convert dBm to dB first. Okay, negative 105 plus 30. So what is the value of dB? Negative 105 plus 30. Please say something.
Negative 75.
Negative 75.
75, right? Okay, now you got value in the dB. Now, from this thing, you must convert to this value, right? dB convert to actual value. So, remember something? 10 log P equals to negative 75 dB. Then P equals to what? 75 divided by 10 anti log. Okay. So what's the answer? Anti log negative 75 divided by 10. So what's the answer? Hmm.
3.16 times 10 to the power of negative 8.
14, right? So this answer correct or not?
Sir,
Silap ke?
boleh ulang balik tak, laju sangat?
Sebab itulah saya telling you something, you kena faham satu benda. Okay, sebab tu saya kata, dia sebenarnya tak laju. Okay, tak apa. Saya tunjukkan kamu. Okay. Tak laju pun, sebenarnya cuma student tak faham sikit je. Okay, tak apa. Saya akan tunjuk lagi sekali. So, slow je. Sebab tu saya kata, okay. Kejap, sebab buka muka surat 58, saya tambah satu lagi, add page. Sebab tu saya kata, okay. Now, saya give you kertas kosong. Okay, kertas kosong. Tulis formula ni. Okay. Formula kita nak belajar hari ni adalah copy dulu sebelum kita buat example. Okay. First, you kena kenal dB. Okay. And then, you kena kenal dBm. Okay. dB and dBm ni, why kita nak guna, okay, why? Kita nak guna, this one term dalam communication. Okay, kenapa kita nak guna dB and dBm? Okay. Let's say, you ambil, katakanlah power. Power equals to 1 million. Contoh example. Kan? Besar tak? Banyak tak nilai? Okay, that's why saya telling something, dalam communication system, you tak boleh design main-main, you cannot play around. Let's say you're missing 1 0 or 2 0, dia akan meletup. Contoh macam mana? Ataupun you tertambah satu lagi 0, dia akan meletup sistem ni. For example, dekat mana kita apply? Dekat Samsung phone, bateri dia. Last time, S7 if I'm not mistake. Oh, not 7 if I'm not mistake. Got problem, right? Because of what? This thing. You tak baca betul-betul. You put value bukan dalam communication punya form. If in communication, you tengok. Let's say you put power kan, kalau dalam dB, kalau ibu put dalam dB, senang je. 10 log 1 million. Berapa jawapannya? log 1 million berapa? Press calculator lah.
60.
Kecil tak value dia? Is it small? Easy to put in the circuit? Circuit for example, yes. Easy or not? Now you see that, okay, sometimes, okay, so clear, okay, now dB, but dB kita ada dua, okay, sebagai tahu something, power dB ni, okay, ni saya nak cerita lagi, dB we got analysis untuk voltage and power. Kalau voltage, apa yang kita nak convert from ini, katakanlah dB, kita ada voltage and power. Pertama kita nak voltage convert to dB. Betul tak? Okay, jadi apa formula kalau voltage convert to dB? 20 or 10 log?
20.
20 log kan? Kalau power?
10.
2 dB? 10 log. Betul tak? Okay. Lepas tu, satu lagi formula yang kena tahu, dB to dBm. Okay, dB to dBm, formula dia adalah kalau nak dapatkan nilai dBm, you must dB plus 30. Okay, semua dah salin tak? Catat dulu, put in your book. Nanti you tak tanya lagi pening. Okay, so clear tak this thing?
Clear, sir.
Okay, very good. That's why you don't come here chapter 1, you don't understand, fail. So can assure you, you fail. Okay, now, so we return back to this example. So let's play with this thing. Okay, relax. Let's play with this thing. Okay, wait for a while, saya nak cancel dulu. Lepas tu saya kata, you know, ini kan guna chapter, semua chapter guna. Nanti you guna chapter 2, AM, analysis, FM, kita guna semua. Ini, that's why ini chapter yang very crucial. Okay, dan ini ada silap sikit. Sebab tu you should come dan you learn. Ini pun tersilap ni, bukan saya punya soalan ni. Okay, now, so in this question, okay, cuba fahamkan dulu. Tengok dulu soalan dia nak apa. Okay, apa yang dia nak? Okay. What is information they are given? Okay. Dalam soalan ni, you kena tahu dalam kes ni, formula direct formula. That's why saya kata, yang ni saya tak risau tau. This part, saya tak risau pun dengan you sebab this is direct formula. Okay. Ini semua sama direct formula. Dapat daripada mana? Daripada sini. Okay, yang ni. Okay, analisis this thing. Sebab tu, this is noise. Untuk analisis noise, saya tak risau sangat. Sebab saya tahu you can do. Okay, student boleh jawab direct. Tapi, you should know something. Dalam formula ni, kita guna actual value. Actual means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7. Itu yang kita guna. Okay, bukan guna dB. Operasi dB hanya ada dua. You can do plus and minus only. dB sebab log. Okay, log 10. Okay, they only can do operation plus and minus only. Okay, now, so apa sekarang ni worried, bukannya worried about you cannot put in the formula. Worried you, this one, dBm. Okay, you dah tahu dah formula ini, saya tak ada masalah, saya tahu, everybody, semua you tahu benda ni. KT, KTB, okay, and then T equals to Pn over K, KB. Ini saya tahu, this one you no problem. Tapi yang student com akan silap ialah this value, ini dBm. Okay, dBm. Kalau, okay, so sekarang ni, kena ingat satu benda. Kalau dBm diberi, you kena faham following. dBm kena go to dB and then you dapat actual value. Okay, sebab formula, you must use actual value. Okay, tak boleh guna dB value. dB value, kalau nak guna tambah dan tolak saja. Okay, clear? So, sekarang ni, cuba tukarkan negatif 105 dBm ke dB. Berapa dBm to berapa dB? So, anybody can answer? Cuba dulu. Berapa jawapan dia?
Negative 75.
75. Why? Because dB to dBm negative 105 dBm plus 30. So you got negative 75. This is formula, saya tak boleh nak tipu you. Inilah formula dia, you kena hafal. Plus 30. Okay, dapat tak? Nilai dia berapa? Di dB. Tapi dB you tak boleh masuk dalam formula ni lagi. Because of what? Dia kena masuk actual value. Now, so actual value macam mana? dB go to real value. Okay. So real value apa tadi? Negatif 75 dB. So macam mana nak dapat? So how you get the real value? Ingat real value nak dapatkan ke dB 10 log P, betul tak? Correct not? Betul tak? So nak dapatkan balik nilai P, you nak dapatkan nilai P sama juga dengan NT log negative 75 divided by 10. Betul tak? Betul tak? So berapa jawapan P dalam actual value? P dalam actual value. Press calculator. Siapa yang tak tahu tukar power? Siapa tak tahu nak dapatkan anti-lock? Anti-lock tahu tak dapat macam mana? Shift log negatif 75 bagi 100. So you got the answer not?
Sir, nak tanya kenapa bukan negatif 30? Kenapa dia positif 30 tambah dengan negatif 105?
Tambah dengan negatif 105. This one. Okay, dia tak ada apa actually. This is a formula, you kena tambah. Kalau tak nak, you kena faham this concept. Okay.
Kalau ikut yang negatif 75 tak dapat jawapan yang patut didapatkan.
Ini jawapan ni, okay. Sebab tu saya kata, you check dulu. Saya tak dapat jawapan ni. Okay. 75 negatif 75 divided by 10. And shift log answer. 3.16 times 10 power of 8
Sebab kena guna negatif 30 bukan positif 30.
Negatif 30.
Ya, sir.
Ya.
Negatif 30.
Sorry. Patutlah sebelum pening. Sorry. Okay, so ini sorry. So ini berapa? Negatif 30 kan? Sorry. This one tolak. Sorry. So minus right? Sorry. Minus right?
Yes,
Correct
sir,
not?
minus 135.
Ya,
Okay,
betul.
1 minus 5. Okay, so what's the answer? Sorry. This was sometimes also
Negatif 135.
negative. That's why negative 1335 dB. Sorry. This one negative 135. Okay, wait. Okay. Negative 135. So got the answer or not?
Got yang
Yes.
ni dapat.
Now good, sir.
Dapat apa? Same answer?
Ya, 3.16 to the power of negative 14 dapat.
Negative 14, right?
Yeah.
Right?
Yes, sir.
Negative 14. Okay, because if you check here, sama kan? Ni, kalau check dekat calculator guna internet, sama kan nampak ni? 3.16 times 10 power of negative 14. Correct or not? Okay? So very good. Okay, sorry. This one is telling something. If you good than me, means I teach you better. If you good than me, you can correct my something like correct me means you are better than me. Means teach you good. Okay. Now, so this one you insert the formula. Okay. So what's the right answer? Actually, this one negative for 14. The rest same. Okay. So what's the value?
Sir,
Yeah.
sir, maaf ganggu sir.
Yeah, no problem.
Kenapa negatif 30 sir? Saya tak faham yang tu. Bukan tambah 30.
Okay, dia macam ni. Okay, kalau you tak faham macam tu, ini konsep dia. Okay, sebenarnya DBM, kalau you tengok dekat internet ni, okay, kejap you tengok dekat internet. Okay, cuba tengok. Okay, The power conversion of dBm to watt given by this formula. Cuba tengok apa yang dia buat tu. Okay. Ini dah formula dia kalau you tahu how to convert dBm to watt. Okay, sebenarnya kalau you dah tak faham, simple macam ni. Okay. Sebenarnya dBm ni, sebab tu saya kata ini nilai baru macam you belajar 1 kg equals to how many gram. That's why you must understand this formula. Okay, so dBm actually 10 log power divided by 1 milliwatt. Sama macam you nak buat cake. Cake maksudnya cake you berapa? Cake you nak buat dalam kg ke dalam gram? Ini adalah nilai you learn, you baru belajar dalam communication. Okay, so cuba you tengok you ambil nilai actual value. Katalah ini P actual value. Cuba you masuk. P, okay, nilai you, P tadi berapa? Yang you kira bawah ni. P ni kan? Okay, cuba kira macam ni. Okay, sekarang ni katalah ambil this value convert to dBm. Okay, so 10 log 3.16 times power of negative 14 bagi 1 mili. Dapat tak you dapat bagi jawapan dia negatif 105 dBm. Cuba kira guna kalkulator. Cuba kira dulu. Dapat tak negatif 105 dBm? Take your time. Sebab ni chapter 1, this was really worried. Chapter 1 you don't understand, tak boleh. Chapter lain easy. So I assure you students A and B only last semester. B only 2 or 3. The rest, because they all understand this chapter. Okay. So, you got negative 105 or not?
Yes sir, dapat sir.
Sebab tu saya kata, sir cannot help you. This is the formula. Contoh, you tanya sir macam ni tau. Sir, kenapa 1 kilogram sama dengan 1000 gram? So, sir say, oh my god. Sir pun tak tahu nak cakap macam mana. Betul ke tak? Correct or not? Betul tak? For example like that lah, macam you tanya kat sir tadi kan. Sir, why 1 kilogram sama dengan 1000 gram? So, sir cannot answer. Try to adapt. Okay, macam sir tadi tersilap sikit nombor lah. Try to adapt the new environment. This is the unit for communication. Okay, so faham tak? So, anybody ada problem? Ada tak yang tak faham lagi? Jangan takut, sir tak ada marah you, sir nak you A dapat E. The rest you tak risau. T over Pn over Kb tu you boleh dapat value sekejap ni. Okay, so what's the value? Okay, tak apa, nanti you buat kira sendiri Okay, yang ni nanti you kira balik sebab this direct formula. Okay, now we go to, ini pun tak apa, direct formula. Now you dah faham dah cara nak guna dB, dBm and so on. Okay, now so nak we focus ni. Okay, kita fokus yang next punya. Okay, yang ni saya takut ni. Okay, now you dah tengok video kan? Kalau gain, apa yang you faham kalau gain? Kalau you kira kan AP, contohnya AP and AV. Okay, apa yang nampak? If the value give more than 1, we get means ada gain. If less than 1, for example 0.9 or negative value, become attenuation. Okay, saya nak tanya you, gain ni bagus ke tak? Saya nak tanya you, gain ni, this gain bagus ke tak? Saya bagi tahu you.
Bagus.
Bagus, yes. Okay, bagus. Okay, so telling something sebab bidang kom, okay, saya suka cerita pasal RFID punya design. Okay, ni saya tunjuk RFID punya design antena lah, for example. Okay, saya bagi tahu something kalau you buat kan satu antena, for example kalau nilai gain dia tinggi, give you the higher gain, antena tu, for example RFID, jarak antara tag dengan reader boleh lagi jauh. Maksudnya gain bagus. Okay, attenuation ni sebenarnya not good. Okay, means they give something like, dia akan, contoh voltage contoh you buat amplifier, contoh you do amplifier or radio amplifier. Okay, kalau you bagi you got attenuation ni maksudnya sepatutnya you buat amplifier so that bunyi sound speaker jadi sedap. Kalau more attenuation, speaker punya sound dah tak sedap. Okay, negative value. This so everybody understand This is the crucial part. You mesti faham. Okay. So saya nak bagi tahu lagi how you get attenuation. Macam ni dapat attenuation kalau gain, kalau apa AP or AV. Okay, AV ni apa? Okay. So asking you, what is the AV? AV ikutlah V out over P in. P out, AP, P out over P in. Okay. Okay. So clear? Okay. So remember, this one saya telling something. Normally, in this chapter we deal with voltage MP. That's why you see sometimes why sir 20 law and 10 law appear because this analysis. Okay, noise, gain attenuation related with dB and then normally related with voltage and power. Okay, now we are over V in. Okay, unitless. Okay, let's say, okay, so telling something before we start. Let's say V out equals to 5 volt and then V in equals to 1 volt. So you got 5. This one, attenuation or gain?
Gain.
Gain, very
Gain.
good. Okay. Now, how about one, same thing, reverse order. So right now, wait, how about so change, so change 1 divide 5. So what's the answer? 1 divided by 5? You got 0.2. 0.2 positive. What's gain or attenuation?
Attenuation.
Attenuation, right? Okay, now you understand this thing? If you understand, so we'll go further. Okay. Very good, Okay, so please take note, please take note, put in your book or notes this formula. Okay. Clear? Okay. And then what's the AV and AP? VR over V in, absolute power ratio, PR over P in. Okay, clear? Okay. Actually, this is concept on amplifier. That's why you see amplifier. R over in. Okay. Now, for example, in this case, this one, gain or attenuation, 25. Gain or attenuation?
Gain.
Oh,
Gain.
very good. Now, that's why I'm
Gain.
telling you something. Now you already understand. This one play around. We give you what? 6 what? Output or P out or P in? P out. Okay. Gate, this one what? A, P. Okay. So you already know what is the input power, play around. Input power means P in, P out divided by A, AP. P out divided by A, AP. Direct formula. Okay. Decibel. That's why I'm telling something. This slide is not do by me. If do by me, so put decibel first. Okay. Now, so you understand, for voltage, or okay, for voltage 20 log. For power gain 10 log. Clear or not?
Clear, sir?
Okay, now let's look on this example. Okay, don't see the answer. Don't see the answer. Okay, an amplifier has the input 3 millivolt. Okay, and the output 5 millivolt. What is the gain in decibel? Okay, right now 20 log or 10 log? 20 log or 10 log? Tell me.
20.
How 20?
Because it's in voltage.
Oh, very good. That's why I'm telling you something. So always telling you, you are my class student, very clever. Okay, because this is voltage. So how to solve it? First, you find the AV bus equals to output V out divided by V in. Out is what? 5 volt. Divided by
Voltage.
V in, right? 3 milli. So what's the answer first? 5 divided by, press calculator, please. This is expensive class because you do synchronize. Synchronize is the expensive class. So you got 1.1666.67, correct or not?
Yes, sir.
Okay. So
Yes.
when you once you got this value, AV in dB equals to 20 log 1666167. So what's the answer? Don't trust the answer. Okay. So what's the answer? So want you to tell me. 64.4. Same. Okay. Now clear? Okay. Now we go to this example. Now power. Okay. Now this one 20 or 10 log?
10.
10 log. Now you already understand. So AP equals to V out over V in. 2 milli divided by 50 milli. You got 0.04. Now AP in dB equals to 10 log 10 log 0.04. So what's the answer? Negative 13.98. So this one gain or attenuation?
Attenuation.
Very good. That's what I'm telling you. Now you become good. Okay. Now we go this one example and this one also similar. You can already know. Now we go to signal to noise ratio. Here you become to understand. So relax. What is the signal to noise ratio? Okay. This one also deal with the amplifier. Okay. Okay. Deal with amplifier. All of these things deal with amplifier. Okay. What is the signal noise to ratio? Okay. Remember, there's another formula. Okay. Don't worry because I love the subject, so can teach you. Okay. Now S and R. Okay. So tell you something. S and R actually we got input and S and R output. Okay. Okay. SNR input and SNR output. Okay. So SNR input, what is the SNR? SNR actually signal to noise ratio. S over N input. This one S over N output. Okay. So since this analysis in power, okay, SNR normally we do analysis in power. Okay. So basically, okay, okay. So we got SNR input, SNR output. Okay. If you want to do this thing in dB, you must do 10 log. This one also 10 log. Okay. Okay. S means signal, N equals to noise. Don't worry, after this you will know. Okay. Just bear in mind, signal to noise rate ratio. Okay. So it is typically measured at the receiving end of the communication system prior to the detection of the signal. Okay. Okay. Often SNR given in the dB. Okay. Now you can keep this formula, no problem. You write down. Okay. After this you will understand. Okay. No problem. SNR dB. Okay, equals to 10 log 10 PS over PN. But sometimes you confuse when I give you this formula at this top, you become understand. Okay, stop at that, and then we go to noise factor and noise figure. Okay, what is the noise factor? Okay, noise factor. Okay, this one different. That's why sir always telling something. Don't make mistake. Okay, noise factor is F. The formula noise factor is F, unitless, and then noise figure in the dB. Now, how to use it? Okay, so tell you something. Okay, noise factor. Okay, take note. F equals to S input over N input, S output over N output. What is this? This one actually SNR input. This one SNR output. Okay, where? From here. Okay, signal to noise ratio. Okay, signal to noise ratio, we got input, we got output. Okay, we got input and also we got our output. Okay, but remember something, here is different. F equals to SNR input. Before this, you learn about output over input. This one different. Noise factor means input over output. Okay, if you don't understand what is the noise factor, noise figure and noise factor are the measure to the gradation of the signal to noise ratio. Okay, that's the thing. Explain something like the relationship between noise factor and noise figure. Okay, how about noise figure? Okay, noise figure. Okay, noise figure is in the dB. 10 log F. Where you got? You got from noise factor. Okay. Okay, so noise figure can be measured using spectrum analyzer. This one appear in your lab. That's why after this you do lab, you can understand easily. Okay, now, sir, I don't understand what we will do with this formula. Okay, relax. So, dah salin tak this thing? Dah salin dah this thing? SN, R, okay, you salin this thing yang saya tulis warna biru ni. Okay, salin dah. Okay, and then you copy this thing. Noise factor and noise figure ni formula dia salin. Okay, remember noise factor is F. Jangan terbalik. Okay, noise factor is F, noise figure and F in the dB. Okay. Okay, dah. Okay, now we go. This is the thing yang kita akan guna relationship dia. Okay, first of all, so nak you understand this thing. Ini adalah ideal amplifier. Okay, this one ideal amplifier. Okay, so dekat sini ada input, ada signal in, signal input. At the same time ada noise input. Dekat sini pun ada S output and juga N output. Okay, signal power out and noise power out. Okay, now the difference between ideal and non-ideal. Okay, ni non-ideal, second one non-ideal. Okay, for non-ideal, there's a presence, ada kehadiran internal generated noise. Itu saja beza dia. Dia ada internal generated noise. Okay, so macam mana saya nak dapat analisis ni? Okay, basically saya tulis dulu. Okay, saya tulis dulu supaya kamu jangan takut. Okay, tambah dulu. Noise factor and noise figure dulu. Okay, saya tambah kat sini. Okay, dekat sini yang saya nak kamu faham dulu. Okay, ideal amplifier. Okay, ideal formula dia S input and input equals to APSI AP and I. Ni salin this formula. Okay, how sir I got this thing sir? I'm become headache sir right now. Okay, relax. Okay, kita tengok dekat gambar rajah ni balik. Sini ada AP power gain, power gain AP. So macam mana dapat formula? Ni senang saja. S input darab APSI. Bawah and input pun dia lalu dalam circuit, dia akan juga amplify. Sebab noise pun amplify, signal pun amplify. That's why you dapat APSI, APNI. Ada siapa yang tak faham? Stop me. Ada amplifier? So you dah faham dah kenapa dapat APSI? Okay. So faham tak why we got APSI dengan APNI? Because signal input masuk dalam circuit amplifier, dia also amplify, so dia dapat APSI. Noise pun dia melalui dalam amplifier, dia dapat APNI. Okay, so tahu tak benda ni? Salin dulu. Okay, clear? Faham? Okay,
Yes.
faham kan kenapa? Sebab saya lukis sini lah supaya korang faham. Sini dalam ni ada AP, sini ada S input, N input, sini ada S output, N output. Yang ini macam mana dapat APSI? S input, dia masuk dalam circuit ni, also amplified. Yang dalam circuit ni pun NI, dia masuk dalam amplifier. Amplifier ke amplify, right? Dia dapat AP and I. So clear tak? Clear? Clear?
Clear.
Okay, now kita go to ideal amplifier. Ideal amplifier ni lah student tak faham. Sebenarnya non-ideal non-ideal. Sebenarnya tak ada apa pun. Okay, non-ideal. Okay, cuba tengok saya tulis dulu formula dia supaya kamu tak takut. S input, N input, A PSI, A PNI plus ND. Okay. Okay, what is the different formula ni dengan formula ideal? Apa beza formula dia? Okay, apa yang beza yang you nampak? Between
Dia
Disturbance.
I itu plus dengan ND.
actually because the presence of internal noise. Sebab tu kalau you nak faham senang je, okay? Because here, okay, in non-ideal, so tell me something. In non-ideal kita ada two element, power gain and also internal noise and D. Sini ada S input, N input, S output, and output. So same lah. So S input masuk dalam ni kat formula atas lah. Saya nak bagi jangan pening. SIP, AP, SI sama je. Bawah you just tambah noise. Kan bawah ni nampak ni ada noise, NI dan juga ND. Boleh hafal tak this formula? Senang tak? Sebab this thing kalau saya tunjuk dia punya calculation matematik you jadi pening. So bawah ni you nampak dia seolah the location of noise. Betul tak? Location of noise. So boleh do derivation tapi nanti you pening. You jadi pening. Baik, better you hafal formula. Boleh tak hafal formula ni? Can you hafal?
Boleh.
Ini je sebab kan this thing simple. Kalau saya tunjuk derivation you jadi pening. Actually ingat dekat bawah ni location of noise. Jangan pula hafal APNI plus APND, no. Tolong hafal APNI, same thing actually. Kalau you tengok ideal sama tak APSI, you tengok kalau ideal dengan non-ideal. Okay. Nampak APSI, APNI sama tak? Sama tak? Is it same? Same, right?
Yes.
Betul tak? Tapi sini ada tambah satu ND saja. Kalau you boleh hafal ni, happy sangat. Boleh tak hafal?
Boleh sir.
Okay, now bila you tahu ni sudah happy sangat sebab we can do this analysis very easy kalau you tahu. Okay, now kita pergi pada analysis ni. Okay, now kita buat apa dia cakap ni pasal apa? Non-ideal ke ideal? Non-ideal kan? Okay, so sebelum buat soalan ni, once you tahu non-ideal, terus tulis dekat sini. S input, N input equals to A, P, S, I over A, P, N, I plus N, D equals to S out and out. Correct or not? S input and input actually signal to noise ratio input. S output and output actually equal to S and R in output. Okay. So, right now, how to solve this thing? Nampak tak? Actually, this thing, value dia dalam real value, betul tak? Watt. Betul tak? Yang ni gain. Okay. Saya nak bagi tahu something, remember. Sometimes game give in dB. Ini real ke dB? 1 million. Real number, Okay, second, because all of you don't turn the microphone, so I don't know what happened. what you're talking about. Okay, now how to solve this thing? Now find the actually input SNR input here, SNR output. Noise factor. What is the formula of noise factor? Formula of noise factor. Noise factor. Noise factor F, right? F equals to SNR input divide SNR output. Okay, how about noise figure? Noise figure and F equals to 10 log F. So suka in Pcom, you write down anything first. You understand, you write down the formula first before we start this thing. Okay, so SNR input. Okay, dalam kes ni dia nak DB tau, DB. So this one 20 log ke or 10 log? 20 log or 10 log?
10.
And then because of what? Why?
Power.
Pandai. This one's telling you something. All of you are good. Okay, now SNR input. Okay, now let's solve SNR input. SNR input, you must see that all the information. SNR input equals to what? SNR input equals to S input divided by N in input. So what? Okay. What is this input signal power? Actually, this one is input signal power as input. Out input noise power. This one is an input. Okay. So to solve question number 1, 2.5, we already know this thing. So we already know this one as input 2.5 divided by 3 times 10 power of negative 18. Correct or not? SNR input. Correct or not? So don't hear your voice.
Correct, sir.
Correct, right? So you got 2.5 divided by 10 power of 18, and then you do 10 log because of what? You want value in dB. Correct or not?
Correct, sir.
Easy or not? So you got the answer 79.2. Easy or not?
Yeah.
Okay. Anybody that don't know, please turn on microphone, so show you. Okay, number A.
Sir, yang solution yang blur je.
Solution apa?
Yang A tu sir.
A? Itu saya kata. Okay, sebenarnya solution A, okay, dia adalah SNR input adalah S input divided by N input. Macam saya kata tadi, ini dia bagi tahu kan non-ideal amplifier. Okay, bila non-ideal amplifier, you kena tengok gambar rajah yang ni, yang saya bagi tahu tadi. Macam mana rupa gambar rajah ni? Dia ada signal power. Sebab tu you tengok sini kan, signal power watt. Sebab apa? Dia adalah power. Lepas tu noise power. Power pun dalam watt. Okay. Signal power output dalam watt. Ini pun dalam watt. Okay. This thing ni dipanggil apa? Yang ni dipanggil SNR output. Yang ni dipanggil apa? This thing? SNR input. Okay. So formula SNR input, S input bagi N input. Okay. So dalam kes ni, ini adalah SNR input. Sama juga dengan S input divided by N input. Tak apa, kalau tak faham hari ni, it's okay. Nanti you boleh recap balik. So faham Ini adalah 2.5 adalah S input. Okay. Input noise power, ini adalah N input. So you ambil formula ni, you ambil 2.5 bagi 3/10 18. Lepas tu kena darabkan dengan 10 log sebab dia dB. Okay. Semua clear tak? Untuk yang bahagian nombor 1. Okay.
Clear sir.
Actually previous formula. Clear? Okay, now we go to output signal noise ratio power. Okay, sekarang ni kalau SNR output, kalau ikutkan kita kena ada S output and output, betul tak? Betul tak?
Betul.
Tapi sekarang ni dalam soalan ada tak bagi S output and output? Ada tak bagi?
Tak bagi.
Tak bagi kan? That's why you kena ingat, you kena hafal this formula. Sebab saya kata once you know this formula, no problem. Okay, nampak ada satu benda ada hint. Okay, sekarang ni kita sekarang ni nak settlekan S output dengan N output. Okay, satu benda yang you boleh nampak adalah ni. You boleh guna formula ni. Okay. AP NI plus ND. You boleh ambil ni. Maksudnya you boleh ambil formula untuk yang kedua, you cari, kita kena cari N out dulu. Okay, N out apa formula dia? Okay, N out sama juga dengan AP NI plus ND. Okay, faham tak? Dapat daripada mana? Ni, N out sama juga dengan AP NI campur ND. Correct or not?
Faham salah.
Correct, sir.
Okay, so AP berapa nilai AP? 1 juta kan? 1 juta. Okay. Lepas tu, darabkan dengan NI. NI berapa? N input.
2.5.
N input.
3 times 10.
3 times 10 power negative 18. Betul tak yang dalam ni? Jadi, you darabkan dengan N input. N input 3 darab 10 kuasa negatif 18. Okay. Okay. And then, campur ND. ND berapa ND? 4.5.
0.5.
Darab 10 kuasa negatif 12. So, you campur dapat berapa? N out. Kira dulu, take your time. Ni tutorial juga, macam kelas with tutorial. So we don't waste time. Okay? Your test 1, chapter 1 and AM. That's why you recap this thing, easy. You already understand everything. Okay, apa dapat?
7.5 times 10 to the power of negative 12.
7.5 times 10 power of negative 12 watt. Everybody got this thing? This one for N out. Clear or not?
Clear, sir.
Okay, now N out you got. How about N out? How about S out? Okay, S out. How about S out? S out equals to, take this formula. S out equals to APSI. APS input. So, AP, what is the AP? AP 1 million. AP equals to 1 million. Don't worry, after this, I upload in YouTube, you check back. Okay. 1 million times S input. What is S input? S input.
2.5.
2.5.
2.5, right? 2.5 times 10 power of negative 10. So what's the answer? S output.
2.5 times 10 power negative 4.
2.5 times
10 power negative 4.
10 power negative 4. So you got an output, S output. Correct or not? Okay.
Correct.
So SNR output equals to S output and output. Correct or not? So what is the S output? S output 2.5 times 10 power of negative 4 divided by N output. What is your N output? N output 7.5 times 10 power of negative 12. Correct or not?
Yes, sir.
Correct, sir.
What's the value? You don't know. What's the value? S output and output. 2.5 times calculate berapa dapat? Okay. Okay ke tak? Ini habis ni you happy dah. Saya pun happy. Saya nak you faham this thing yang susah, yang lain senang. This thing je yang saya takut you tak faham. Okay. So berapa jawapan? Siapa yang dah kira tadi? 2.5. Ni. Kira yang ni. 2. SM output and output. 2.5 times 10 power of negative 4 divided by 7.5 times 10 power of negative 12. Berapa jawapan dia? Output.
3.33.
Apa?
33.33.
33? Oh, sorry. 33 times
10 power of 6.
10 power of 6 or negative?
Positif sir, positif.
Positif ah.
Ah.
10 power of 6. 3.33 times power of 6. Okay. Lepas tu ini actual value. Kalau you nak convert in dB, 10 log listing. Betul tak? Berapa dapat?
75.22.
Ah,
8. So 75.23.
75.2 kan? Sama lah macam jawapan ni. So sudah want to double confirm. So actually we do tutorial sekali. Okay. So now bila you dapat sekarang you dah settle you dah dapat SNR input in dB, SNR output in dB. Now you cari noise factor and noise figure. Yang ini senang you clear, so you clearly understand dB and no dB. Okay. The real value and not real value. Okay. Noise factor, I told you something. Okay, this thing. Okay, back here. Okay, there's a two type. Kalau you clever, you boleh guna number 1. Kalau you tak clever, you jangan guna. Okay, kalau you pandai, saya bagi tahu you. Kalau you pandai, if you are clever, this one for clever, clever boy, clever girl. Okay, remember something. Saya pernah cakap kan, kalau you want to do in dB, what is the operation that allowable for dB? Plus and minus, correct or not? And minus, correct or not?
Yes sir.
Okay, now saya nak tunjuk magic. Okay, magic kita kan kita boleh proofkan ini kalau you nak dapatkan nilai dalam dB. Sometimes, sebab tu you kena tengok soalan. Sometimes dalam soalan ni, okay, kadang-kadang dalam soalan dia nak noise factor and noise figure, noise figure kan? Noise factor and noise figure in dB. Sorry, bukan dalam dB. Ni. Okay. Satu cara dia, okay, kalian nak dapat noise figure, okay, noise figure lah. Ini kalau cepat you want to double check kan. Noise figure, apa formula noise figure? Formula noise figure, sorry ni. Formula noise figure 10 log F. Okay, 10 log F. Ni sebagai tahulah kalau nak kira you dapat jawapan tu betul ke tak. Okay, so 10 log F, okay. Ini tadi you dapat, okay. Noise factor ini untuk noise figure je if you want to check, ini dapat kan ni 3 point, kalau ikutkan noise figure 3.79 dB, right? Okay, kalau noise factor ni you kena kira lah manual lah, actual value divided by actual value. Okay, kalau noise figure in dB kan dia bagi tahu dalam soalan, right? Noise figure in dB, dia tak lupa tulis. Okay, noise figure in dB, okay, lupa tulis. Okay, now dB ni senang je, you cuba cari SNR input dB, berapa nilai dia tadi you kira? SNR input dB, SNR input dB dia kira 79.2, right? 79.2. SNR output dB equals to mana tak nampak, 75.2. Cuba you tolakkan dua-dua ni dapat berapa? 79.2 minus 75.2, you dapat 3 point, you dapat 4. Actually nearby this value. Sebab apa? Sebab tu saya kata you kena faham konsep. Okay, noise figure tak apa, kalau ini cepat lah kalau you want to check. Okay, macam that's why saya beritahu jawapan you betul ke tak. Okay, ini cara cepat. Sebab apa? Seno operasi tambah tolak. Okay, now ni kenapa tolak? Because operation of bahagi. Kalau you tengok sini, ni sebagai ajar you lah. Because of what? Sini operation dia bahagi. Okay, noise factor. Yang ni ini bahagi. Okay, bahagi. Okay, sorry, ni bahagi. Okay, now so clear? Okay, yang tak apalah kalau you tak faham tu, okay. For those tak faham tak apa, okay, sepadan balik. Ni cara secek lah, secek cepat. Kalau you buat salah ke apa, saya boleh tahu. Okay, now kita dapat kembali kepada asal noise factor. Okay, noise factor, what is the formula of noise factor? F equals to SNR input. Jangan takut, SNR output, SNR output. Okay, this one kena guna actual value. Jangan guna dB dB tak boleh bahagi. Okay, you SNR input berapa? Actual value. Ini actual don't put dB. Actual value berapa? 83 kan? 83, 133, power of 6 divided by SNR output. 33.33 10 power of 6, you dapat 2.5. Faham tak? Macam dapat noise factor. Okay, noise figure pula. Noise figure equals to 10 log 2.5. Dapat 4 dB actually. Plus minus lah. 3.9 pun also can. 4 dB also acceptable. Okay, now you understand or not?
Yes, sir.
Understand Okay. If you understand, so actually already finished. Okay. Thank you. Wait, so stop the recording first. Sedang record ah. So record. Wait. Okay, stop recording.